I've been studying how the Earth revolves around the Sun. A long time ago, they decided that every time we complete one revolution would be 1 year. So, let's see how far we travel each year. Oh my gosh, we're zooming through space at 67,000 miles per hour. And in one orbit, we travel 580 million miles. I thought the shape of our orbit was a circle, but the Earth's orbit actually changes from a circular to an oval about every 50,000 years. When the orbit is an oval, the Earth goes farther away from the Sun during the year, and because it's so far away, winters are very, very cold. So cold that we have an ice age. And then it takes another 50,000 years to change from an oval back to a circle. And goodbye ice age. So that got me thinking. No matter how warm it gets, no matter how much carbon dioxide we put into the atmosphere, no matter how much money we spend, sooner or later we're going to have another ice age. Now, I know the next ice age is a long way off, and I know we have to take care of our resources, but a planet that travels over 1 billion miles every 2 years at such an amazing speed, this huge change in its orbit has to be a suspect. So it looks like we have our suspects, but before we line them up, let's take a look at how much has been done to fix things so far. Well, there sure have been a lot of arguing. Senator Whitehouse says it is astonishingly irresponsible to be in the predicament we are in right now, with what is fair to describe as a looming global emergency that we can't get anything done on. Maybe the Environmental Protection Agency, the EPA, can sort this out. They have a clean power plan, and if we go to their website, they say all states must submit initial or complete plans by June 30th, 2016, with the option to use a 2-step process for submitting final plans if more time is needed. They also stated they wanted to cut carbon dioxide emissions from existing coal plants by up to 30% by 2030 compared with 2005 levels, taking aim at the nation's leading source of the greenhouse gases. They don't say how, though. Senator Sanders wants to create a carbon pollution fee, and he has submitted a bill that he wants to make into a law. He wants to charge each coal-fired electricity generating power plant $20 per metric ton of carbon dioxide that it produces. Since a typical coal-fired electricity generating power plant creates approximately 3.5 million metric tons of carbon dioxide, each coal plant would have to pay the government $70 million every year. And that doesn't include methane, which is also in his bill. And he also built into the bill a 5.6% increase each year. And there are over 600 coal plants. I hear the cash jar open, but I don't see much of a fix in any of that. So my goal was to follow the clues to prove human use of fossil fuels caused global warming and climate change and figure out how to solve the problem. As I questioned each suspect that kept leading us to other suspects, we even found a couple of accomplices. It was time for a good old-fashioned lineup. That's where I looked over the suspects and see if I can figure out who was guilty. First up, human use of fossil fuels. There must be millions of web pages on global warming and climate change. Even the government and university websites are crammed with them. I could never read all that stuff, and I don't think anyone else could either. That's one reason we rely on the people that run things to sort it out for us. But the more pages I do read, I find one thing in common. It looks like the most of them used only 2 numbers. They looked at the temperature going up, and they looked at the rising amount of carbon dioxide going into the air from the human use of fossil fuels. And that was that. And when the temperature stopped going up, all that carbon dioxide in the atmosphere had to be having some effect on the weather. From the NASA website, a minor but very important component of the atmosphere, carbon dioxide, is released through natural processes such as respiration and volcano eruptions, and through human activities such as deforestation, land use changes, and burning fossil fuels. Humans have increased atmospheric CO2 concentration by a third since the Industrial Revolution began. This is the most important long-lived forcing of climate change. And then there's the headline from the EPA site. Humans are largely responsible for recent climate change. Based on all that, I have to conclude that human use of fossil fuels is a solid suspect. Our second suspect is population growth. Since 1970, the world's population has just about doubled, from 3.7 billion to 7.2 billion people. The population of animals we eat has grown as well. That means there is a whole lot more carbon dioxide going into the air from exhaling, and methane. As the population grows, so too does the amount of waste and garbage, which produces even more CO2 and methane. Our growing population is still a suspect. And now, let's take a look at our third suspect, volcanoes. According to the EPA, volcanoes don't really emit much CO2 compared to the burning of fossil fuels. It is 135 times larger than the highest preferred global volcanic CO2 estimate. That's about 1%. It sure seemed like volcanoes would be responsible for a lot more carbon dioxide, but article after article say the same thing. My tech support team read a lot of papers, studies, and reports, and they all point in the same direction. 1%. Volcanoes are no longer a suspect, but they are an accomplice. Next up, changes to the coastline. Water is very powerful. Water carved the Grand Canyon. Everywhere that the water meets land, water always wins. Currents, waves, earthquakes, and storms cause erosion. Along the coast, storm surge from hurricanes is often the greatest threat to life and property. The material that is eroded winds up somewhere else. Levees, jetties, and pumping sand onto beaches can work for a while. But as soon as a big storm hits, all that could be washed away. We saw that after Hurricane Sandy. Stockton University reports the fact is, however, that both of New Jersey's southernmost communities were sand-starved as major man-made structures and indirect development caused changes contributed to the shoreline instability. Coastline movement changes where currents travel, and currents move temperature around the oceans. Changing ocean temperatures creates wind. Wind moves climate around the globe, so changing coastlines changes climate. Suspect. And that brings us to the sun. The sun definitely affects climate change and for sure global warming. But let's add a couple of examples. If our atmosphere contained only nitrogen and oxygen, the Earth would be an ice ball because the sun's energy would just be reflected back into space. There has to be a greenhouse gas to absorb the heat and give us the temperate climate necessary to survive. The right amount of each of those gases is what I call the magic blend. And it is that magic blend that acts just like a windshield on a car. It protects us as the planet speeds through space. NASA reports that carbon dioxide causes about 20% of Earth's greenhouse effect. Water vapor accounts for 50%, and clouds account for 25%. The rest is caused by small particles and minor greenhouse gases like methane. And more from the USGS. While we worry about possible global warming from the additional CO2 we put into the atmosphere by burning fossil fuels. If there was no CO2 in the atmosphere, the global climate would be significantly cooler. Of course, if you want solar panels everywhere, you gotta have sun. And then there's all that data from NASA showing the solar system warming. at about the same percentage as Earth. Planetary warming, heating the dark water, the evaporative cycle, wind, solar power, it's all about the sun. The sun is therefore a strong suspect. I tag continental drift as an accomplice, but I decided to give it another look after changing coastlines made the lineup. Huge chunks of land moving across the surface of the globe are going to affect where the wind goes. If wind is changed, so is climate. But as I studied the movement of tectonic plates, I discovered that a lot more is going on. First of all, the Pacific Plate, which lies beneath the Pacific Ocean, covers 103 million square miles. This is over half the planet. When this baby moves, climate has to follow. The Ring of Fire is a circular arc of the active volcanoes that surrounds the Pacific Plate. Fault lines and space between the plates allow gases to leak into the atmosphere. From Caltech, an analysis of gas grab samples showed relatively high levels of CO2 in borehole air at Lake Hughes and Lytle Creek, along the San Andreas Fault. CO2 outgassing is easy to measure because you can drive right up to the spot and take a reading. And those pesky volcanoes line the plate. 75% of the Earth's volcanoes are on this ring. This allows lava and gases to escape as well. The rim of the Pacific Plate is referred to as the Ring of Fire. It is 26,000 miles long. That is a huge ring. And there are 23 other smaller lithospheric plates with more than 270,000 miles of seams, fault lines, ridges, and gaps where degassing takes place. The most exciting thing about this project was emailing back and forth with Professor Tobias Fisher. Professor Fisher advises on the University of New Mexico research on carbon and methane emissions from volcanoes. He told me that volcanoes might account for 3% of the CO2 in the atmosphere. The cool thing about that is his project in year 5 of a 10-year study. He told me that since more people live near volcanoes, there is a larger number of people to report volcanic activity. And that got me thinking. Volcanoes are simply the events that allow the pressure from heat and gases to escape. There are 20 active volcanoes right now, and the USGS has identified over 1,500 total. As I watched all the snow pile up in the Northeast this winter, I wondered how much it all weighed. And then I wondered if all that weight would have an effect on volcanoes. Since the tectonic plates are actually floating on the top of the molten center, it seemed that all that pressure would act like a toothpaste tube. Squeeze down here, toothpaste comes out. There. And then the Villarrica volcano in southern Chile erupted. I won't say I saw it coming, and it probably was a coincidence, but I am starting to see how everything is related. One thing happens, and that causes something else to happen. Water and air temperature affect how fast lava cools, and the sooner it cools. The faster the trapped gases are released, the time of year, the latitude, the duration, the depth of the ocean, and what type of tectonic plate it belongs to all have an impact on CO2 emission. I have to reorganize my notes. I never thought this mystery covered such a huge amount of information. I hoped all I had to investigate were those two numbers. How much CO2 humans were putting into the atmosphere by burning fossil fuels and how that affected global warming and climate change. And there's that curious study done by Terry Gerlach. I don't know what to think of that. But thank goodness for computers. And a very nice soft chair. I'll see you in chapter 4.